Yes.
Yes. Yes. Okay, here we go. So you're going to do for an XY system of linear equations for Cramer's rule, you're going to come up with 3 determinants. And the nice thing is with this, these are 2 by 2 determinants. Okay, so what are our 3 determinants we're going to come up with? We're going to come up with the general D determinant, and then a D sub x, and then a D sub y. Those are the 3 determinants you're going to come up with. Okay, and then those are going to be used to find x and find y. So what is the D determinant? The D determinant is you are just going to take your coefficient matrix 2, 3, 3, 4. So you take your coefficient matrix and then you do the determinant of that. So you have one general D, I call it for determinant, that's what the book will call it. That is your coefficients, 2, 3, 3, 4. All right, we talked about this yesterday, doing the determinant, we kind of reviewed it, right? And so what do we end up with? 8 minus 9 is negative 1, okay? Now the D sub x, okay, is also going to be a 2 by 2, but what you're going to do is you're going to take your 7 and 10 and replace it for the x's, and then leave your y's actually. So that's kind of funny, is that you think D sub x, you leave your x's, replace your y's, but you're replacing your variables that you're looking at. Okay? Now D sub x is not what x equals. Okay? So what do we get? 28 minus 30, negative 2. And then D sub y is you keep your x's and then replace your y's with your constants. So just taking the constants and replacing the y's. And then you end up with 20 minus 21 is negative 1. Okay? So then to find, because now that's our 3 variables, so then to find our variables, I'm struggling with that. How do I find x? Well, x you're going to take, and you're going to take d sub x divided by d, and y is going to be d sub y divided by d. And so it's negative 2 divided by negative 1, which is 2, and negative 1 divided by negative 1, which is 1. And there you go. It's easy. So yeah, that's all there is to that, Cramer's rule. We'll do an example of a 3 by 3. Which the cumbersome part of a 3 by 3 is you have to do.
Would you just add one more?
Yep, it's a D sub z.
Okay.
And so it's the same concept, but the issues, the determinants are not 2 by 2, they're 3 by 3. Right. So then you would have 1, 2, 3, and 4 3 by 3s to find determinants of. So let's just do one example, make sure we're on the same page. But again, general determinant is your coefficients. And then to find the determinant with x, you take your constants, replace the x, leave the y's. To find y, you take your constants, replace the y's, leave the x's. And then to find x, it's dx over d. To find y, dy over d. Okay, so then let's go ahead and we'll do an example here. Some of these in the book for the determinants, they make them kind of nice for you. Is that, and I'll give us an example. If we have x plus y plus z is equal to negative 2, x plus 3y. X plus 3y plus z is equal to 0. That's what I wanted. X plus 3y plus z is equal to 0. Then x blank plus 4z is equal to negative 2. Negative 6y plus z equals 1. Okay.
Oh, wow.
So now you can actually do this with a system of equations. I'm going to explain that briefly, but then we'll do matrices. If I want to do a system, if we have a system of linear equations like this right here, I would hope at this point all of us could, maybe you'd have to review it briefly, but all of us could solve that. All right, guys, solve. Okay, we're going to multiply this by 3, multiply this by a negative 2, get rid of the x's or whatever, or substitution, right? So if we can get it down to 2 variables and 2 equations, you can find x and y. If I knew what x and y were, couldn't I find z?
Yes.
Yeah. So what you can do is you could take like these two equations, in this case it's actually really easy because it's missing a y. Well, take these two equations, subtract, get rid of your x's,
Okay.
and then you'd be left with a y and a z, right? And then you take that equation that you just found with y and z, combine it with this equation with the y and z, and then you could find y and z.
And then you could also
And then you,
find
then
X
you
from
go
that.
back in and plug in for x. So that's actually a valid way to do it, and it's not like necessarily cumbersome, it just takes a couple extra steps. So you take two equations, get it down to two variables, take a different two equations and get it down to the same two variables. And then you would have a system of linear equations, solve for those two variables, plug them back in. Okay, cool.
Substitution works for this as well, right?
Yeah, substitution could work where x would be equal to, you know, negative 2 minus 4z, so negative 2 minus 4z, so you have a z and a y, and then, yeah, you can do that. So, okay,
There are missing variables. Can you do the same add subtract without the missing variables as well?
yeah, it just is a little bit more work. But here, missing variables represent what's the coefficient? 0. So on the test, we're going to say use Cramer's rule to solve. So all you're going to do is you're going to take for d, okay, d equals, and we're going to go like this. You're going to get 1, 3, 1, 1, 0, 4, 0,
Negative 6.
negative 6, 1. Okay. Now, we talked about yesterday by minors. Minors works amazing when there's 2 zeros in any row or column. 1 0 isn't bad. You know, you can do that. So it's just kind of up to you what you'd like to do. Diagonals actually work well when there's zeros in there too, for diagonals. So if we were to do, just as a review, diagonals, we would take the first two columns, right? And then transpose them out here. And then this actually works out pretty nice because you take this, these three multiplied with 0, plus 0, and then you get to negative 6 minus, right? The quantity, these three things added together. So what's the first one?
0,
0,
negative 24,
negative 24, plus 3.
Yep.
So that's a negative 21.
Yep.
Plus, turns into plus. So
Positive
you get
15.
15. So D is equal to 15. Okay? So then you take your constants, and if I want to find D sub x, right? What am I going to do? What's the 3 by 3?
0,
by 3.
negative 2, 1.
0, negative 2, 1.
Then 3, 0, negative 6, 1, 4, 1.
Okay? So I took my constants, put them in place with my x's, kept my y's and z's. And you take that. You guys want to do minors for practice or do the diagonals?
Let's do minors for practice.
Minors for practice. Which row or column? What do you guys think for a minor?
There's a 0. And
There's a 0.
1 right there.
First row?
Let's do
First row?
first row, yeah.
Okay, so first row, you're going to take the first element. If it's 0, then do you even bother with it?
No.
Nope, so let's go to the second element. What do we need to remember about the second element?
Also 0.
No, so put the 3 out in front.
And then it needs to become
Negative.
negative because it's plus minus plus, right?
Yeah.
So 3 times this 2 by 2, which is what's the 2 by 2?
2, 1, 4, 1.
Negative 2, 1, 4, 1,
Yeah.
right? Because that gets canceled like that, and then the top row does. Okay, and then it's going to be plus or minus?
Plus
Plus
1, which you don't
1
really need to.
times.
Negative 2, 1, 0, 6.
Get rid of that, get rid of that. Negative 2, 1, 0, negative 6. And let's do our mental math. Negative 2 minus 4 is
6.
negative
Negative
6.
No,
Negative
it'd
6
be
times
plus. Because
negative
you're
2.
subtracting a negative.
Oh, well, no.
No, it's negative 2 minus 4.
Oh, minus 4. Never mind. That's my bad.
Negative 6 times a negative 3, 18. And then plus, or it could end up being minus, but 12 minus 0 times 1, so plus 12.
30.
So you get out 30. And, okay, so now if you want to find out what x is equal to, take
Oh,
dx over d.
yeah.
So 30 over 15.
30 over 15, which is 2.
Okay.
So what I would allow you to do on Cramer's rule on like a 3x3 if it was the test, once you know x, which is 2, can you easily find z?
Yeah.
Yeah. So for that, I would allow you just to do Cramer's rule to the point where
You can solve
you
it.
can solve it by plugging in. So, meaning you just have to show, like in a 3x3, you have to, like in this case, you just have to get this, you know, which, 2 diagonals, I'm sorry, 2 determinants for 3x3s and then plug in. Okay? And then once you have that, I'd be fine with saying, hey, now you could keep going and find dy and dz doing what we just did, right? And then plug in. But I'm okay on the test. You show me, hey, I got d and I got dx in this case. Now I know that x is 2. I plug in. And then z is equal to -1. Then once you have x and z, you can plug in or have z right there and then solve for y.
Yeah. Simple.
Questions on Cramer's rule?
Nope.
No. Pretty simple. Pretty good stuff.
Pretty straightforward.
Pretty good stuff.
Okay.
Yeah, everyone
Okay.
uses the bathroom.
You bet.